In this slidecast, we'll talk about the list class and the iterator. Now, the list class is part of the C++ standard library. It's defined in the header list. It implements a double linked list, and the following slide presents a subset of its functions. So here are the functions it provides and a description of their behavior. Notice that since it's a template class, many of the parameters are of some form of an item type. You can get the front and the back of a list. Iterators, we'll talk about here a little bit later. Some of these functions return iterators or const iterators. Other functions require iterators as parameters. There's a swap function to exchange the contents of a list with another list. We have the size of a list. So go ahead and pause the slidecast and look through these more carefully if you'd like to understand the details. Now, the subscripting operator that you use with arrays and vectors, it's not defined for the list class. So instead, an iterator serves as a moving place marker. It keeps track of the current position in a particular linked list. And then iterator can be advanced forward using the overloaded plus plus operator, or it can be backwards using minus minus. So here's an example of a list. So it's a double linked list. It's not a circular list. And here's an iterator that points to this current node Harry, and parent refers back to the list class that's managing this list. Now, we use an iterator like a pointer, and the pointer dereferencing operator, the star, returns a reference to the field data in the dnode object at the current iterator position. So the list table that was shown on the previous slide, and it was showing again, has 4 functions that manipulate iterators. So insert adds a list element at the position indicated by iterator, and erase removes the element at the position indicated by the iterator. Begin returns an iterator that's positioned at the first element, and end returns an iterator that's positioned just before the last element. Actually, that should be just after the last element. That's an error here in the slides. So it's positioned just after the last element. So here are these functions. So notice here's the correction. The end returns an iterator that references the end of the list. So it's one past the last item. Now, using an iterator preserves information hiding because the internal structure of the dnode isn't visible to clients. So they can't manipulate the list other than with the public functions. So clients can access or modify the data, and they can move from one dnode in the list to the next. They can't modify the structure since they don't have direct access to the previous or next data fields. Assume that iter is declared as an iterator object for a list, and we can use the following fragment to process every element of the list instead of the one that was shown at the beginning of the section. I believe this one looked at the pointers directly. So here in this for loop, the first initialization parameter declares this iter to be of type iterator. In fact, it's a list item type : iterator. So this is an iterator over a list, over this template class list. Now, it's a set equal to the iterator that's returned by the call to begin, and that returns an iterator that points to the first item of the list. Now, the test parameter causes the loop to exit when the iterator has passed the last list element. So as long as we're not at that last list element, then we'll continue in our for loop. And the update parameter advances the iterator to the next position in the list. And then we do something with this next element. Using the dereferencing operator, we can grab the next element in the list, and it's of item type. An iterator is a generalization of a pointer. And here's a for statement that accesses every element of array, and this is written different than we usually do. We're not going to use the indexing operator, and we're also not going to use the size of the array. But notice we set up next as a pointer to the beginning of the array, and until next is equal to an array plus size, that's points one item beyond the last item of the array. Then we'll just increment next. That'll point to the next integer in the array, and then we can dereference this pointer to get the next integer in the array. So this just shows how we can kind of process an array much in the style that the iterator uses. So the for statement just discussed have a form different from what we're used to. Now, to test for more nodes in the list, we compare the current iterator position with the result of a call to end, and that's the iterator position just beyond the end of the list. And we have to say not equal to the end. We can't say, for instance, use the less than operator. This is discussed in your book, because the items of the list don't have to be in order in memory. They can be randomly arranged in memory. So we can't compare the pointers. And the prefix plus plus iterator rather than this postfix increment is more efficient. Every container in the standard template library has to provide an iterator and a const iterator type. And the only difference between these is that the return type of the pointer dereferencing operator. So this operator star. So an iterator returns a reference, and a const iterator returns a const reference. And you can see that here, for instance, in the dereferencing operator, returning a const reference and just returning a reference. And the const reference is required for every iterator except output iterator, and the reference type is required for all iterators except input iterators. And it returns a reference to the object referenced by the current iterator position. It can be used on the left-hand side of an assignment statement, and the const is used on the right-hand side of an assignment statement. Because on the left-hand side we're making a state change. On the right-hand side is read-only. So here's a diagram that shows the different iterator types, and this is sort of a conceptual hierarchy, and it represents a common interface that generic classes must meet. And so we've got an input and an output iterator, and we've got a forward iterator, bidirectional iterator, and a random access iterator. So you can use an iterator to remove an element from a list as you access it, and you use the iterator that refers to the item you want to remove as an argument to this erase function, and then erase returns an iterator that refers to the item after the one you removed. And you use this return value to continue traversing the list. You shouldn't attempt to increment the iterator that was used in the call to erase, since it no longer refers to a valid list node. So assume a list of integer values, and to remove all the elements that are divisible by a particular value, here's a function to do that. So it takes in a reference to a list and some divisor. And here we initialize an iterator to point to the beginning of the list, and while we're not past the end of the list, now the expression star iter, that's the dereferencing operator, so it gets the value of the current integer referenced by this iterator, and if it's evenly divisible by the divisor, then we call erase to remove that element from the list. And this function returns an iterator that references the next element. And then we can use the prefix plus plus because we don't need to copy the iterator prior to incrementing it. Now, removing elements from a list. If we have a list of string values, we want to locate the first occurrence of a target value and replace it with a new value. So our parameters are a list, the target value, and the new value. We initialize an iterator variable, and while we're not to the end of the list, then we can compare, using the dereferencing again, the current item in the list with the target. If they're equal, then this does an assignment to replace that value with a new value, and then we break out of the while loop because we're just modifying the first occurrence. Otherwise, we advance the iterator. And that's the end of this slidecast.